Alright guys, welcome back to my video series. Today we're going to be basically creating a VPN IPsec tunnel between the ASA on this network, go across the internet service provider, and connect to this ASA on this subnet. And it's basically going to simulate, let's say, building one using a VPN IPsec to communicate with building two. But just a heads up, this video is going to be long, probably close to 30-40 minutes, because there are a lot of configurations, and I'm going to be doing both of them. So I'll do a command here on ASA0 and then do it over here. And that way I don't lose track of um, my what I've done. The hope is that when this is all done, everything will work fine. If not, that's totally fine as well. We will go through the troubleshooting phases. And even if it does work, I think it's still valuable to um, actually make another video later on, just showing some of the troubleshooting commands that you can use. And I'll talk about some issues I had my first IPsec VPN tunnel. It took me like an hour to figure out something so basic, as far as like the basic issue. All right, so let's go ahead and get started. We're going to break IPsec VPN down in two phases. Phase one is basically, um, if you can think of it as the initial configurations as like, okay, we have device A and device B. We know we want to communicate. How should we encrypt data? How should we hash it? Or how should we be able to? How would we know if it's the same data that we sent prior? Um, let's go ahead and get started. So our first command is going to be crypto Ike version. We're going to use Ike version 2 for this demonstration. Um, and I am looking for policy, and we can use any number you want. I'll do 10 because it's easy for me to remember. Just know we are going to match this one as 10 as well. They have to match or it will not work. So let's go ahead and out of the options that we have here, we need encryption, group, integrity, lifetime, PRF, and then we also need to enable this on the outside interface. So let's get started. We'll start with encryption option, AES 256. Encryption is basically just providing confidentiality for the data. It scrambles the data and only the corresponding peer can unscramble it. So, okay. And the other one is integrity. When we use SHA-256, you can use anything you want really, just make sure it matches with the corresponding peer. I'm using 256 just because it's going to be really easy for me to remember because both encryption and integrity, while these are not the same thing, if they both end up in the same, like 256, it's easy for me to remember. And integrity is basically when this, like, let's say this device is sending a packet over here. Um, Before it sends over, the ASA will include a hash into that packet. It's basically verification that the packet hasn't been tampered with. It's going to go over the internet encrypted and with a hash. This is going to unencrypt it, and it's going to look at the hash and just double check it's make sure it's the same as the hash that was given to the by the ASA. All right, so let's go ahead and include group. We'll use 14. You can use anything here. Just make sure it matches with the peer. 14 is the most common from what I've heard. I wouldn't use anything depreciated. I don't know if you can actually do that. I haven't tried. And this is just basically saying how should we handle like the setting up of the keys for the initial exchange. All right, so we say group 14, and let's say PRF. PRF is pseudo random function. It helps. I'm not 100% sure exactly the specifics behind it. I'm using SHA-256 again just to make it easier. Everything's 256. Um, but it helps with generating the keys for the initial setup of the IPsec communication. Lifetime, I think, is optional. But let's just configure it 865400. I guess that's, I don't think that really matters, to be honest. Question mark, that should be all. I'm going to say also exit. Question mark, I'm going to say, uh, let's see, crypto, Ike version 2, enable. And we want to enable it on the outside. It's always going to be the outside because if you think of how this data is going to travel through the VPN, it's going to go this way. And even on the other corresponding device, data is going to go that way on the outside. So it's always outside. Outside. So that is done on this side. Let's jump to ASA 1 and do the same thing on this side. Exit crypto Ike version 2, policy 10, encryption AES 256. It's pretty fast, guys. I know you already saw it on the other one. SHA 256. Oh, what happened? Okay, I didn't like the space. That's all right. 256. PRF SHA 256. Group 14. Lifetime seconds 865,400. And then I'm gonna question mark just to make sure I didn't miss anything. Everything looks good. Exit, we'll say crypto Ike version 2. Oops. Crypto Ike version 2. Enable outside. Congratulations, guys. Phase 1 is done. Now we're start going to the second phase of the configuring the IPsec tunnel. Let's go back to the other ASA device. All right, so from here, let's start off with the command crypto again. Crypto, let's say Ike version, oh, whoops. Now we're going to specify IPsec because now we want to enable, specify the encryption and then hashing method of the actual IPsec tunnel. So IPsec Ike version 2. We're looking for the first option, IPsec proposal. Once you've done the configurations for this a few times, you'll realize that it's almost always straightforward with these because you have to think that we're making a VPN IPsec, and then you'll see IPsec proposal. And that's usually okay. I'm making an IPsec. This is probably the command that I need. Okay, IPsec proposal, question mark. Now we have to name it. Since we're using an ASA device, let's just say ASA proposal. Something easy to remember. Question mark. We're looking for, as you can see on this command, nothing here is really helpful. Okay, the irony itself is probably helpful. But we need protocol. That's really the only thing that we can use here. ESP, that's basically the protocol that IPsec uses. And then we're going to specify the encryption for IPsec. Let's just go ahead and the same as the last one, 256, protocol, ESP, integrity, unrecognized. What did I do wrong here? No. Question mark. Okay, protocol. I forgot protocol. Integrity. SHA-256. And that should be all there that I'm pretty sure of. Yeah, so we can say right, exit. We're going to do the same thing on the other ASA. Guys, forgive me if I'm saying that wrong. I'm actually not in the networking field at the moment. Okay, so let's go ahead and go to crypto, IPSEC, like version 2, IPSEC proposal. Same, we're gonna name the same thing here. Whoops. Proposal. Okay, same things. Protocol, ESP, integrity, SHA, options 256, protocol, ESP, encryption, AES 256. Right. That's it. All right. So now we move on to the next step. Okay, right. Let me move this out of the way. I think it's stopping me from clicking on that. All right. So let's go back to the original ASA on this network. Okay. So this is true for even if we weren't using a VPN and we wanted to traverse the internet, specifically to different networks. I can ping these devices already, but I wouldn't be able to ping this without a specific ACL. And it's the same thing for the VPN. We have to basically tell the ASA, hey, I want devices in network 192.168.1.0 to be able to communicate with devices in 192.168.2.0. So this network to this. The way we do that is we configure an access control list. So access control list. We want the first option. We're going to name it. Let's just name it. Okay, so traffic on a VPN IPsec that we want to be able to traverse the tunnel is called interesting traffic. So let's just call it allow interesting traffic. Something easy to remember. All right. And we are dealing with IP addresses. So we want extended. So if you look, it says configure access policy for IP traffic. That's what we want. Extended. Permit. Let me pull this up a little bit. Okay, so I need to permit IP. And we want the first option. We will add the IP address of source IP. I believe that has to go with the subnet mask. And now we want to communicate with the destination IP. So we'll say 192.168.2.0, 255.255.255.0. Question mark. And that is it, guys, for the access control list. I will be right back. I'm going to go to this ASA and just do the same thing. So exit. We'll say access list. Allow interesting traffic. Extended. Whoops. Wait, let me just make sure it's extended next. Oh, yeah, it is extended. Extended, permit, IP, and then our source for the peer network is 192.168.2.0, 255.255.255.0. I think that's it. Okay, no, it's not. Sorry, guys. 192.168.1.0, 255.255.255.0. Awesome. Our access control lists are set on both devices. Now we also want to configure, right now we have NAT that's allowing us, well, PAT that is giving these guys a public IP when it hits this interface, and these guys a public IP when it hits this interface. But we just configured an access control list saying we only want this network and this network. So if we don't include an exemption, when this network gets its public IP of this interface here, the VPN will drop that packet because it's no longer this IP address. So we had to create an exemption. In order to do that, it's quite easy. We'll go object. What am I doing? Sorry. Object network. Let's name it. Okay, so object local net subnet 192.168.1.0 255.255.255.0. Cool. Now I'm gonna go to object remote net. Uh-oh, what happened? Okay, I see what happened. I forgot this part. Object network subnet. So the remote net is what we're going to be talking to, which is this side, which is 192.168.2.0, 255.255.255.0. Okay. And now we will specify our NAT exemption. So we'll say NAT inside, outside, question mark, source, question mark, static, question mark. Okay, so we have to specify our local net to our local net. Guys, to be honest, I don't remember why we had to type in the same object twice to make this work. If you know, please tell me. Destination, static, and then we'll say object remote at object remote net. Then question marks, so options, no proxy ARP. It will still work with proxy ARP, but this should help remove any kind of annoyances. Okay, and now I gotta do the same thing on the other side. So we configured our objects. Whoops. Object network obj local. Oh shoot. Local net subnet 192.168.2.0 255.255.255.0. Perfect. Okay. Object. Whoops. Object network. OBJ remote net subnet 192.168.1.0 255.255.255.0. Now we do all net exemption, net inside, outside, source, static. Okay, then obj local net, obj local net, destination, static, I think. Let me just check. obj remote net, obj. Oops, that's not gonna work. obj remote. Oh wait, messed up. No proxy ARP route. Okay, cool. So that's that. I don't remember if I. Oh yeah, okay, I did. And I did. I was thinking I forgot to enable the crypto IKE version 2 phase 1 onto the outside interface, but I'm pretty sure I did. Okay, so the next step is basically now we will utilize DOMAT. And this is where we state that, hey, ASA, I need this to work for this. Okay. Oh wait, no, I'm sorry. I got one more step. Conf T, we'll say tunnel group. Now the tunnel group is gonna be the we want to have tunnel group with the outside interface of the peer. So let's go ahead and do that. 173.16.2.2 question mark type question mark IPSEC. And like I said, it's easy to figure out which ones it is because it always tells you IPSEC. Tunnel group 173.16.2.2 IPSEC attributes. This is where we make the key for IPSEC. IQB2. Okay, local authentication pre-shared key. I'll just say 123. I know, guys, it's not the best. But if we get a message, we got to do it on the remote as well. So that's okay. We can do that. Nike version 2, the remote, pre-shared key, 123. Just make sure the pre-shared key matches on both sides or it will not work. Yeah. So let's go ahead and do that on the side as well. All right, so tunnel. Oh, I don't know if conf t tunnel group 173.16.1.2 question mark type question mark IPSEC L2L tunnel group 173 dot, oh, my battery's almost dead, dot 16.1.2 IPSEC attributes, I think is what it is. I'll type IPSEC, wait, question mark type. Okay, did I mess up here? Oh, shoot, I think I did mess up. Look at that. Let's just do that again. Tunnel 173.16.1.1. We're just going to do start over. Type IPSEC L2L. I'll delete that one later. I don't think that really matters, honestly. Tunnel group 173.16.1.1 question mark. Okay, IPSEC attributes. Question, well, we'll start. Question mark. This is where we do IK version 2. Oops. IK version 2. Local authentication free shared key. 123. Okay. Question mark. IK. Whoops. IK version 2. Remote free shared key. 123. Right? Okay. Now, this is the very last step. We are going to configure the crypto map. It's relatively easy. Let's say this is basically going to put everything together. Call it outside map 10. Match question mark address question mark. This is where we match our access control list that we made. I made them both the same on each, so it should be easy. Allow interesting traffic. Question mark. Okay, that's it for that. Crypto. That one's the hardest one because it's not like the option is different. It's matched where everything else is going to be set. Set. Peer. Okay, a peer. The peer for the ASA on the VLAN 10 is going to be 173.16.2.2. Yeah, that's the right one. Question mark. Perfect. Crypto map outside map 10 set IK version 2 IPSEC proposal, and we named it ASA proposal. All right. Now we say crypto map outside map, and we're gonna interface enable. Outside, sorry. Right, and that should be it for that ASA device. Let's go to this one. So same thing. I know the commands all look the same, but make sure your peer is mirrored. They shouldn't be the same. 10. Match address. This is where we can include the ACL. Allow. Interesting. We're just typing in the name of the ACL. All right. Crypto map outside map 10. Set here 173.16.1.2. Crypto map owned by computer. Aside map 10. Now we have to specify the proposal that we used. Set like version 2. IPSEC proposal. ASA. Okay, crypto. If you get an error when you're doing the crypto map, just check your wording for your like when you typed your word for your ACL and for other things, because if you get an error, it's not going to work. Crypto map outside map and interface outside. So hopefully it works. Tunnel's done. If it doesn't work, no big deal. Next video we will troubleshoot. Even if it does work, we'll still go over troubleshooting um commands that we can use. Yeah, I'm not gonna squeeze the troubleshooting in this video. It's just the video is too big already. Ping 192.168.1.1 2. I'm gonna see if this Ubuntu device can speak to this Ubuntu device. Might take it a minute, but okay. So it doesn't look like ping's gonna work. That's totally fine. In my next video, stay tuned because we are going to troubleshoot it together, and we're going to use a whole bunch of commands that you should know if you do configure VPN IPsec, because you don't want to just remember the commands. It is helpful because you do need to know how to do this if you want to configure VPN IPsec, but you also I feel like troubleshooting is more valuable. You have to know what you're looking for, where you could have messed up, where you could have forgotten, maybe a very slight mistype. I know last night I did this and I spent an hour troubleshooting because I had my tunnel group one digit off. Instead of, at the time, my peer was 10.10.10.2 and I had it at 10.10.10.20. And just that little detail will make your VPN IPsec not work. But thank you guys for watching. And please stay tuned. The next video, we're gonna go right into the troubleshooting. All right, thank you.